Recording in progress.
That's better. I think that's better. Well, it'll get brighter in a little while. Awesome, awesome, fantastic. All right, so well, we'll give more people a chance to join class. Meanwhile, you guys should feel free to switch on your cameras and then start, start talking to each other. By the way, does everybody know where to go and check your previous quest scores? Everybody know where to go and find out how much you got in your previous quests?
I actually just figured it out.
Who? Sorry, who said that?
Robert.
Oh, Robert. Okay. Yeah, you figured it out?
Yeah,
okay.
I figured it out.
Okay.
Yeah, I did get trophies for that quest, but it shows up as a 0 on Canvas. So
just resubmit. Just resubmit with your student ID, and it should show up with the points. Okay, and then let me know.
Yeah, it did.
Do you know how to put your student ID?
I think they were always there. Yeah, I know my student ID. I put it
well,
in
that case, if you did submit with your student ID, it shouldn't show up as 0.
It didn't show up as 0.
No, if it shows up as 0,
No.
you got to fix that. Let me know and fix that, because that will transfer over to Canvas.
Only on Canvas. I was looking on Canvas and it showed up as a 0.
No, Canvas. I have to manually, import it from the question system. Yeah, on /Q. What does it show on /Q?
It shows like 12.362.
Yeah, okay, so that's the score. Okay, so whatever it shows on 12, whatever it shows on /Q is what will make it into Canvas. Does that make sense?
Yeah.
Yeah, and anybody could go anytime and enter your student ID or whatever the ID is, right? It doesn't have to be a student ID. So you put your name there. Yeah, you enter that handle into the /Q site. It'll tell you all of the quests, when you completed them, what your last submission time and date was, and how many points you got for that. The only thing to keep in mind is that the score that will get transferred into Canvas is the last submission. Okay, so if you actually manage to ace the quest by fooling around trying silly experiments just before the day when things get imported into Canvas, and you screw up your scores because your experiment didn't work and you forgot to submit the right file again, that means the 0 will make it into your Canvas. Okay, so just make sure that even if you do experiment, just make sure that the last submission is the right one. Okay.
All right.
Yeah. Is everybody else okay? I mean, yeah, you should just talk to each other for about 5 minutes. Okay, we'll start as usual in 5. And today, the plan I think was, do we have the code from last class? We don't really need the code from last class, but if there's stuff that that we need to fix that we did last class that we need to fix, we can fix it now and do something else. Last class, did we leave our code in a running state? Did we actually manage to run it? Sadhvik, yeah. Did we actually manage to run it and fix all the bugs and it was working? Okay, awesome. Great. So I like the approach that Sadhvik you took. You posted something in the Reddit saying, you can do it with one loop. Was it one loop version? Did you post it or someone else?
No, it was me, but I think Cecilio uploaded his version as well. So.
Oh, I see. Okay, yeah, good. Well, I haven't looked into the details, but the one loop version is certainly possible, and it's a really worthy, thing to try. So the only minor change to what Sadhvik suggested is you don't need to have that, which was very clever, by the way. You leverage your mathematical. The mathematical knowledge we can get from the problem statement, saying, well, the maximum number you can ever get to is 50 because multiply the 2, so you can have the outer loop go from 0 to 50. But technically, you don't need to put an upper bound. You can actually recurse to infinity in the in that loop, And just make sure that you have two counters. I basically just increments by 1, which is the index, and it will stop as soon as I hits the limit of the array. And the other counter is n, which gets assigned, and it'll just skip not assigning. And I don't know if that makes sense, but I think that's the crux of the cleverness in Sadvik's solution, right? So if you tease it out, that's basically what it is. And if you implement that, it'll work beautifully. So yeah, excellent. So I'm very pleased to see these things. And again, these are the things that also teachers like in general is when a teacher poses a problem in class, later on when you're doing a grad course or whatever it is, just solving the problem that's been given. Yeah, it's okay, it's fun. But what most people like is solving the problem in a slightly different way, maybe. Or maybe, extending the problem, saying, hey, I can actually improve it by saying, I don't need 2 nested loops. I can do it with 1 loop, right? Or I don't need to make these assumptions about the domain and things like that. Those are things that are really, really valuable. So I like that. Thank you. So yeah, again, I remind you guys to switch on your cameras and do talk to each other. Clarify any questions you may have amongst each other for a few minutes, okay? And then we'll start. Okay, so I'll just check my email for a few minutes until then. No silence though. You got to keep talking. Talk about anything, but if there's silence, then I'll have to look up and start participating again, because I think I would be led to believe that you guys are just waiting for me to talk. Okay, so just talk amongst yourself. You guys want me to talk? There's so many things to talk about, right? There are so many things. You don't have to talk about C++ or CS2A, right? Talk about anything you want, because I just need to know that there's people here,
Yeah,
talk about something you saw on TV yesterday, or some cool link you got on Facebook or TikTok, right? I don't care, right? We're just waiting for more people to join us, and then talk about anything you want, right? And eventually, all of these things will lead into what you're interested in, and you'll find that all roads lead to Rome, or something like that, right? So if you're interested in programming in C++, no matter what you do, you're going to try and tie this into it, right? Because everybody wants to fire on all cylinders on everything they do, right? So when you start doing something, it's like, well, you know what? I know this other thing, and let me try and bring that to bear here, so maybe I can do an even better job. Okay, so people are always going to try and do better and better things by bringing in other pieces of knowledge they have. Once they get satisfied with the state of the art or something like that in what they're currently doing, they'll bring other stuff in to enhance. All right, so yeah, please go ahead. I was going to check my email and I didn't, because you guys were silent.
I was wondering, when people were doing Quest, I think 3, I was having trouble, because it wasn't I wasn't compiling when I was submitting it to the website, and then I had to reread the spec sheet, and I realized that you have to include any main, and then I was like, oh god, and it was 15 minutes before the thing locked, and I had no idea what was going on. I'm glad I had to reread it, because I ended up working after I deleted all the mains, or the main, but I just thought it was funny. I don't know if anybody else maybe ran into that at all.
Yeah, I had a similar difficulty, not with Quest 3, but I think it was something with Quest 2. I don't super remember. I was trying to get it to work on Xcode with all the code that was giving within the Quest. And it just was giving me a bunch of error messages. And I was like, well, if it's not working here, it's certainly not going to work within the Quest. But that was exactly what the Quest wanted. But in my mind, since I was so obdurate, since it wasn't working on Xcode, I was reluctant to submit it. I don't really know what I was thinking.
Yeah, I gotcha.
But yeah, I kind of learned my lesson there, because I spent hours, multiple days. I was like, oh, I can bang this out in 30 minutes to an hour. And no, Which I did. I actually did, but I couldn't see it. I wasn't
Oh, yeah.
working it.
That's funny. It's funny how those things work. Smallest thing.
Did anybody feel the earthquake on Tuesday?
Yeah, or I actually didn't feel it, but everyone around me did, and I heard that from multiple people too. It's weird. Weird.
I didn't feel it, but I got a notification on my phone. I got a couple of bell sounds, and it's different from my email and all the other notifications. So I went to take a look at the phone, and it's like, oh, there was an earthquake. So as I was very eagerly looking out for the aftershock, saying, oh, well, at least I'll feel the aftershock. I was looking out and nothing happened. So.
Has anybody here done, I guess, any research in any CS language or like area of CS? Aside from, I guess, Professor.
No, barely. The closest thing I've ever come was within a genetics lab, but we use bioinformatics. We weren't researching computer science. We were using computer science to research genetics.
Got you.
Okay, all right, great. So are we guys ready to start? We can start working on some code. Yeah. So what do you like to do? Do you want to pick up do you want to pick up Tuesday's code that Sadhvik was working on and then enhance it more? Or I actually did have an idea yesterday, okay? And we could do that. And I thought it was going to be a really cool idea because what we'll do today, we can extend to, well, what we'll do today, let's set the motivation for classes and objects. And then next class on Tuesday, when we're going to start talking about objects, we can take what we wrote today and turn that into object-oriented code, which is really cool because you'll actually see why we need objects in the first place, right? So, because we start object in C++ and object-oriented programming with a motivation, saying, why do we need objects? And we can, because everything you can do with object-oriented programming, you can do without objects too, right? So that technically, and and being computer science students, you would all probably already know this, or you will know this very soon, that any language out there, take any language, okay? I'm talking about the standard computing paradigm, not quantum and all, okay? So standard computing paradigm, any language out there, if you take any sophisticated problem coded in C++, Java, Go, Erlang, any language, right? So, and it could be millions of lines of code. You print it out and it's like this huge stack and all. Even that can be programmed completely in C or assembler, right? A machine code. You can write everything in machine code. Because, think about it, the computer, after all, is just a sophisticated version of a Turing machine. Yes? And a Turing machine does not require anything. It doesn't even require electronics. You can work on a piece of paper, right? A piece of paper with dots and dashes. And that's basically a Turing machine. Yes, because you could have your finger move on the dots and dashes, and a dot could mean something, and a dash could mean something, and a sequence of dots could mean something, and a sequence, right? And you can keep jumping back and forth. Essentially a Turing machine. It's just going to take you ages to do even a simple thing, right? Printing something on the screen and all, but it'll work. So theoretically, a Turing machine can solve any computational problem. That's what it means when people say it's computable, right? So when people say, is that computable? Is it not computable? Right? So eventually, some of you may do research, right? When you do research in a theory of computation, because theory of computation is itself a very interesting, vast and interesting field. Okay, I'm not even talking about the theory of computation moving into quantum computing and all, which is a different paradigm, right? Theory of traditional computing, huge field, because there are problems that can be solved computationally, and there are problems that cannot be solved computationally, right? So someone tells you a problem, and you say, well, I can solve it. I can't solve it analytically or mathematically, but I can solve it computationally. And they say, what is computationally? And they say, well, computationally means I just do one little step at a time and it'll get me closer and closer to the solution. And eventually I'll get a solution. That's a computational solution, right? Now that person could say, no, right? You cannot solve it computationally because even with your approach, if you do it one step at a time, you believe it's taking you closer and closer to the solution, but it's going to take you an infinite number of steps to get, to get close. So you can never solve that problem computationally. So there are problems that resist computational attempts to prove, solve. And in fact, you can prove that there are some problems are computationally intractable, right? Meaning that, if you give that problem to a computer, it's going to take exponential time, or, super exponential time, or even there's no known solution, even exponential. Right? Because even if it's exponential, you can say that, Turing machine complete, it will eventually complete and say, like after 10 billion years, the program will complete, right? Like deep thought. You know about deep thought? Anybody know about deep thought? The Hitchhiker's Guide to the Galaxy? Wow.
Is that
Okay.
like
Well,
where it's trying to
it's a very
find
interesting- You want me to
it's
tell
trying
you
to
the story?
find the meaning of life, right? Something like that.
Yeah. Do you want me
Comes
to tell
out
this
with
story?
the-
It's a very nice, and it's appropriate for computer science too. You want to know, how many of you want to know the story? Raise your hand. Okay, all right. So this happens in a far out universe, okay? I think Star Wars, far out universe, where there's very, very intelligent advanced creatures, like trillions of years ahead of us. So they want to find the solution. So they've solved all computational problems known to man, let's say, right? And they want to find the solution to life, the universe, and everything. I believe that's it, right? I've such a long time.
The meaning
they
of
wanna
life,
find
the
this-
universe, and everything.
Yeah. What is it?
The meaning of life, the universe, and everything.
Oh, so yeah, that's what Adam said. Okay, the meaning of life, the universe, and everything. So they want to find. So they said, well, you know what? I think I can build a computer that can find the answer to that. So all the best minds in that great alien civilization get together and build this computer, which can solve this problem. And they say they proved that this problem is actually Turing complete. I don't know if the right terminology for it is Turing complete. It is solvable. Okay, it is computationally solvable, meaning that the answer to this question does not require a new paradigm, right? Using the paradigm of computing known to us. I'm going to increase the screen size, okay, because you guys are so small. Okay, that's better. Okay, so this computer will solve it eventually, right? Not right now, eventually. And so, how long is it going to take to solve the problem? Well, it's going to solve the problem, but it's going to take not exponential time, not even super exponential time. It's going to take huge amounts of time. So, even though it's a small problem, it's going to take 7 billion years to solve the problem. Okay, 7 billion years. So they say, all right, okay, well, we have nothing better now, so let it run. Okay, so they start the program and it starts running. And the program, this computer that they built to crunch through this problem is called a deep thought. Okay, they call the program, the computer, deep thought. So deep thought is running for 7 billion years. 7 billion years, obviously, the people who built the computers, they're all dead and gone. Okay, many generations have come and gone. So their descendants, right? Finally, 7 billion years later, their ultimate descendants go in front of the deep thought computer and say, hey, deep thought, our ancestors from eons ago gave you that problem, and today you're supposed to have the solution. What is the answer? Okay, and then finally the computation grinds to a halt. So we've got the answer now, and so they ask the computer deep thought to print it out, and a ticker tape rolls out, and they read the ticker tape, and the answer to the question of life, universe, and everything is 42. Okay, it says the answer is 42, and these guys couldn't make head or tail out of the answer. Say, what the hell, man? I asked you for this question, and you spent 7 billion years and lots of electricity, and you give us the answer, lame ass answer, 42, right? And the deep thought says, well, that is the answer to the question you asked. And if you want the answer to the question that you wanted to ask, you got to ask me the right question. Okay, if you ask me the right question, I'll give you the right answer. But the question you asked, that's the answer. Okay, and so these guys said, well, all right, okay. So we stuffed ourselves. So how do we find out what the right question is? And so they said, well, another clever descendant says, well, you know what? We have a computer. This is an incredible computer. Why don't we put that problem to the computer? Okay, we'll ask the computer what is the right question to ask for the answer you just gave us. Okay, and that they proved that it's computationally tractable, right? It'll give you the answer. So they asked deep thought, what is the right question to ask? Okay, and and I believe at that point, the deep thought says, well, I can find the answer to, I can find the right question, but it's going to take me 7 billion years to find the right answer. Oh, geez, there's a 7 billion years to find the right question, and it goes tinkering away for another 7 billion years. Boy, I actually forgot the last bit of
No.
this story. What happens after that? Does anybody know?
Yeah, so he then says, well, he can't do it, but he can build a computer that can find the answer.
Yes.
And
Thank you.
that computer is then the Earth.
Thank you. Yes. Okay. Well, what Nemo just said. Okay. So after 7 billion years, the descendants of the descendants go to deep thought and say, well, you know what? The ancestors gave you this question, this problem, saying, what is the right question to ask? And then deep thought says, well, you know what? I've crunched a long time, and I found that even though I'm like the super duper God computer, even I can't find the right question to ask. However, because I'm so much better than you guys, I can build a computer that can ask the right question. Okay. So he says, all right, how long is it going to take to build a computer? He says, well, it'll take me 7 billion years to build that computer. And that computer is going to be called Earth. And all the components in that question will be these people, right? And these people are these cognitive units, higher level cognitive units. They'll work together and find the right question to ask. Now, is that a cool question, cool story or what? Right? Very nice story. And also it sets a stage for computer science in general, right? What is computable? What is not, right? And you can you find the answer using this technique? So those are interesting things. That in fact there's another it's a smaller, okay, not a big story like that. Another related story, I think, which I used to tell in class. This guy in the desert is driving along, and he finds a crashed spacecraft. And so he goes, oh my gosh, spacecraft, and he looks in the wreckage, and there's an alien in there and just about to die. So he pulls the alien out and does resuscitation and all, and brings him back to life. And the alien says, I'm so grateful to you, Earthling. I will, because you saved my life, I will give you anything you want. Because I'm an alien, I got like superpowers and all, I can give you anything you want. So ask me any question and I'll give you the answer to that. Okay. And so this guy thinks for a while and says, hey, he's a clever guy. Okay, he's a clever guy. And he says, well, you know what? That will tell me the answer to any question I ask. But what question should I ask? Should I ask it, what is going to be the price of this stock on the stock exchange tomorrow, right? Because once you know a little bit, you can basically be a killer, billionaire beyond imagination. Because, in finance, that little bit of information makes a huge difference, right? So he thinks, oh, even that's no use, right? So I want to find the ultimate best question to ask. Okay, and unfortunately I can't find the best question to ask. So let me try and play the alien. Right? It thinks it's so intelligent, but I'll show the alien that I'm even more intelligent. Humans are even more intelligent than aliens, because I'm going to give you a question that you'll be forced to give me the answer whether you want it or not. So he says, well, Mr. Alien, what is the best question to ask, and what is the answer to it? Okay, so that's cool, isn't it? Because deep thought, they got screwed because they asked one thing. So he says, here's my question. What is the best question, and what is the right answer to it? Okay, and so the alien, who this guy thought was not as clever as this guy, came up with a cool answer. What is that answer? Can someone tell me that? Take a guess, okay? Take a guess. It's really cool. It's really cool. And it's connected to deep thought and all, okay? It's connected to deep thought. Well, not connected in that way, but it's related. It's similar kind of thing. Similar kind of thing. So what?
It's the same question that he asked. It's the same question that he asked.
And no, but the question was, what is the question and what is the answer to that? So you're very close, Never mind. Very close. Well, was it Andrew?
I'm not Andrew. I'm not Andrew.
Oh, Robert.
I'm Robert.
Robert, yeah. Because Andrew was moving and I was looking there. So yeah, very close.
He repeats the same question back at him. That's
yes, but what is the answer? Because he asked for the question and the answer to it too.
Does the alien get stuck in an infinite loop of answering the same question over and over again?
Well, it's a clever alien, so it's figured out all the corner cases. Okay, it's figured out the corner cases once it gets stuck. Okay, so all right. So the answer that alien gave is actually super duper clever if you think about it. It says the best question to ask ever is the question that you just asked me, just like Robert said, and the correct answer to that is the answer I just gave you, right? And that was fantastic, isn't it?
I think
so
that's
it is the answer, and then the alien just disappeared into space-time, bam, like that. So no more chances for more questions. So you would actually been better off. He asked, well, what is going to be the price of Microsoft on, on NASDAQ tomorrow? Okay, so so that was really cool. So, all right, okay, so that's enough, waffling today. So if someone wants to take the screen, ideally someone who doesn't want to switch on their cameras today, so at least we'll know that they have a screen presence, and also someone who hasn't taken the screen before. So I'm looking at Connor, Andrew, a whole lot of people volunteered last class to take the screen, right? So any of you can basically take the screen. It doesn't have to be someone who doesn't have the camera on. Yeah. The Darshana also coded, I think. So, but if you're free to take the screen, from next week onwards, we'll open up the coding opportunity to anyone, even people who have coded before. But ideally, it would be better if someone who hasn't coded takes the screen. So here's the idea I had yesterday. What we'll do is create a, because I was really thinking of that game we developed where this runner, the two runners going towards each other. I thought it was really cool, and I didn't really want to give up on that. So I thought, okay, well, let me try and salvage some of the ideas and see if I can do something with it. And I thought, okay, well, we'll create a simple one-dimensional screen, right? One-dimensional screen on our big screen. We're going to create a one-dimensional screen, and then we're going to write methods that will go and put stuff on the screen, okay, in various places. And then we'll also be able to create animation effects. We're using that sleek thing, right? So you can have characters moving around on screen and all on one line, just one line. And we can achieve that effect using the /r character that I showed you. This /r means print the line, but don't go to the next line. Print the line and go back to the beginning of the same line, so that if you print another line, it's going to overwrite the existing line. So by doing that, we can get the flipbook effect, right? You print a line and then erase that, print the same line over again, different characters, and you keep doing that, the characters will appear to jiggle, right? So in my mind, it looks kind of cool, but it's, the proof is in the pudding. So we'll be able to try it out today and see if it works and it's cool. And by the way, when I said last class, we're not going to do big projects and all, right? And this thing that I just mentioned is no more than about 40 or 50 lines max, okay? Small program. It's going to be simple, super duper simple and easy, and then we'll still have opportunities for other people to code today in class. So anyone who wants to take the screen, take it. Well, this time I think it would be better, although not necessary, it would be better if we do it on a Mac, because of the terminal. Unless on a Windows also you can get some kind of a terminal. It works on Windows too, because ANSI codes, /r is basically universal. Yeah, it'll work on Windows too. We just have to get to that terminal and run it by hand. That's all. So it doesn't matter which one you want to. Yeah, someone should just take a screen. Tell us who wants to code today and take the screen, and then we'll start coding this really cool project. I hope it'll be fun. Okay, and then I hope this will give you opportunities to extend it into some more cool things that you can talk about in the forum. And I'll give you ideas too, right? At the end, I'll give you some ideas of how you can extend this more and all. But the high level view is essentially, it's very simple, okay? We're just going to create a function which will print a line and /r, and then rewind to the beginning of that same line, okay? And then in your main or some other calling function, you're going to say, well, put a dot in that place, put a line in that place, and so on and so forth. And it'll do that. And then when you start draw the line, it'll print the same line again, right? On the same place, in the same place. So essentially you can draw the line and then, and fiddle with it, and then draw it again, fiddle with it, draw it again, and you can do that in a loop in your main. And I think it'll be really cool. And it'll also give you a very good idea, right? And I don't know how many of you are interested in game development. How many of you are interested in graphics and game development? You're raising your hand if you're interested in graphics and game development. Great, just one person? Yeah, okay, cool. So there's a few people interested in graphics and game development. Graphics is really cool, and we're not doing heavy duty graphics, like, later for 2B, well, 2B students. Okay. So I'm going to tell Thomas 2B students, if anybody is interested in doing a, very simple graphics program, that, just uses ASCII characters on a screen and draw 3D shapes and with hidden line removal. So you have a cube that's rotating and the lines in the back are not, the wireframe can't be seen because it's an opaque size, right? It's actually possible to implement, right? Using just 2B level knowledge, it's possible to implement. And I need to check with the 2B students if they'd be interested in doing that. Okay. So the challenge with 2B students really right now is that even though the strength has dropped because a lot of people have dropped class, and but I think it's purely online and the lectures are not mandatory. And so the challenge with them is really trying to make them all find a good time for them to attend a session like this where we could all code together. Okay. All right. Who's all right? Rich, Andrew, great. Andrew, first time you're sharing a screen, right? All right. Right. I can't hear you, but I can see you.
Yes. Hi.
Awesome. Okay. So let's put our usual comments on the top and saying what we're trying to do today, so that people who look at this file will know this is what we're trying to do. And I bet is this a Windows machine or is a Windows machine?
Yeah.
That's fine. All right, we'll just compile it and then we'll compile it and then we'll run it. Yeah. Are you? We'll figure it out later. But are you able to figure out after you compile it? If you copy this and put it into, can you compile stuff on your computer, on your local computer?
Yes.
Good. All right, that's fine. All right, we'll get to that compilation place later. We'll develop it here and then copy and paste it there. Okay, so put a comment right on the top saying.
Actually, I do have a thing currently where with the compiler that I'm using, the thread function that we were using to have the whole thing sleep like 1 or 2 classes ago doesn't actually work for me, but it should work on here. So if we're using this, it should be fine.
Oh, that's really strange. So you're saying RAND didn't work on your Windows machine?
It didn't. I was using a thing. It was Ming GW64, and there's some extra libraries and stuff for it, but I think I just need to get a separate one.
Huh. Yeah.
Yeah, it's really weird.
I don't know. I can help you out.
What's up?
If you don't mind me asking, what are you using for like compilation? Is it just like you've installed the compiler to your computer and you're just you're just typing the command into the terminal or whatever?
VS Code.
VS Code. Okay.
Yeah, I have it.
I don't know why it's doing that then, because it was working for me. So if you want, I can try and help you at some point, like one-on-one.
Yeah, definitely, 100%. I spent one of the whole class times just trying to search how to fix that, and I couldn't find it. There's so many people just saying you have to get an entirely separate library. That was out of the thing. By the way, sorry.
Okay, that's great. So you guys can make a time and on Zoom or something, and Adam should be able to do it. And there's also more people. If Adam doesn't have time or something, also Walter is also there. So there's lots of people with VS Code experience. I think I'm not a VS Code expert, right? So Adam and I think Walter, maybe Adam, and a few other people can help you with VS Code. All right, great. So let's go right to the top and say today's code, today's date, and class code for I think what is it, 26 or 27? 26 today. What is today's date?
27.
27. Yeah, sorry. Okay, and then you can say today we're going to play around with functions, parameter passing by reference, copy, and static variables inside of functions. Okay, so those are the 3. Let's not be ambitious and put in lots of stuff that we don't manage to cover. But basically, that's all we need to do for the midterm, I think, right? We already did arrays. So that's all we essentially need to do for the midterm. But that's not the reason I'm stopping there. I think more than that might actually be challenging. Not challenging, but maybe pushing it a bit. So just before, in week 5 before the midterm. So, all right. And on the next line, we'll say we will make a function that will maintain a one-dimensional screen of 80 columns. Of 80 columns. 80? Yeah, I think let's stick with 80. Okay, 80 columns as an internal static variable, as an internal static array, right? As an internal static array variable. As an go to the next line because it will wrap up. Yeah, okay. Internal static array variable. Oh, yeah, okay. Wow, okay. So yeah, I was just thinking this more through, and we need to maintain this. Unfortunately, the screen itself can be maintained inside the function because we're going to be writing 2 or 3 different functions that will be manipulating the screen. So remove the word static, okay? Remove the word. In fact, we will use, we're not going to make a function and all, right? So I will make a function, but that's not going to use the, we will, here's the thing, okay? Don't do this when you're programming in real life. We're going to write the code and then put the comment in saying, well, this is what the code does, okay? Usually people say, hey, this is what we want to do, and then write the code, right? So we're going to do the code, and the reason I'm doing that is because the code will be very self-documenting and clear, and you'll get a very good idea of what it's doing, and then we can put the comment in. Is that okay with you guys? But essentially, what we want to do is we have a 80 character thing, and then that's our screen. We put stuff in there and print it out. Put stuff in there, print it out. That's all we're going to do. Okay. All right. So okay. All right. So let's say in main, inside of main, let's create a variable array for our screen. So, and let's say it's a character array. So characters, char, C-H-A-R, and call it screen, and then square bracket, 80. 81, right? Make it 81. No, actually, no. Make it screen size, uppercase, all uppercase, screen underscore size. No. The parameter, the inside the square brackets. Inside the square brackets, you say char screen size, all uppercase, with an underscore between screen and size. And on the previous line, semicolon after that, yeah, on the previous line, you want to declare a const size t, screen size, and make it 80 columns for now. Yeah. And we're going to do one thing, okay? And I'll explain the reason for this later. On the next line where you have screen size within square brackets, make that screen size +1. Okay, screen size +1. Okay, all right, great. Now, what we want to do inside of main, we have the screen. So imagine that you have the screen, and the screen is one strip of, it's just one line. One line is your screen, and you're going to write into that. So inside of that, let's say on the next line, we're one more blank line. We're going to call a function. We're going to call a function that will initialize the screen. Okay. So let's say we want to say initialize the screen. Okay. So call a function saying initialize underscore screen, and pass it the screen as a parameter. Now, is everybody clear with what Andrew is doing? Because he is coding as though he has a bit of experience already, right? I don't know if that experience could be from before even he enrolled in class, or something he picked up in the last 5 days, weeks. But at the same time, I want to make sure that everybody's on board. Okay, I don't want anybody to be left out. So if anybody feels that what Andrew's typing is too fast, or what I'm speaking is too fast, you should let us know so that we can slow down. We want to go at the slowest possible speed. Okay. Hey, Mark, you have a question?
Yeah, so the constant is because it's not changing. Like we're not gonna
Yes.
change it.
Yes.
And you can't change a constant, right? Like you will get an error.
Yes. Yes. If
And
you
I
say
know.
something is a constant, yeah.
Sorry, go ahead.
No, if you say something is a constant, the
Mhm.
compiler will have you back and say it'll prevent accidental changes to it.
I see. I know in Python you do like all caps for constant. Do we do that in C++? For
So,
naming
by the way,
convention?
in Python, is all caps a convention that programmers use, or is it enforced? If it is all caps, it's automatically a constant. Is it in Python?
I'm pretty sure it's a convention. I don't think you can do a constant in Python because it's a dynamic language.
Yeah, it's just a
Oh, I
convention.
see. I see. I see. So there are no constants, but if you use all caps, programmers generally know to back off
Yeah,
and not change
exactly.
it.
Mhm.
Same thing here. Same thing here, except that not only programmers, even the compiler knows. The compiler will have your back too.
Right.
I don't. Why
Wait,
don't they
so
do
are
this
you
in Python?
saying? Wait, are you saying it's all caps in C++ too for naming convention for constants, or not really?
My convention, okay? I'm not saying it's the
Oh,
universal
okay.
convention, because I've seen code out there,
Okay.
even written by professional programmers out there. Some of them use lowercase too for constants. So, and then it's really cool code. but I use all caps. Does that make sense?
Okay. Yeah, it
Yeah,
does.
it's just strange, but Python should be doing that too, because in Python, they already enforce aesthetics in the program, right? They enforce, if you don't have the right indentation, the program won't run in Python, yes? Indentation is
Yeah, for
enforced.
some of it, like the
Yeah, for some of it.
indentation is very important.
Yeah, so they should have enforced this too. I'm saying if it's all caps, it's got to be a constant. This is, how it's a simple tweak to the compiler. It's just 2 lines in the compiler code. Writing the compiler, they could easily do
Mhm.
that. I don't know. They may have other reasons for not doing that, but it seems they should do that. Okay, initialize. So and put a comment there saying on that line saying this function, this function should clear the screen and place a /0 in column screen size, okay? \0, by the way, okay? \0 in screen size so that it can be printed out as a string, right? Because a string needs to be terminated. If you don't have a /0, then the runtime system doesn't know when to stop printing the string, because the string is just a series of characters. So unless you have a /0, that is called a sentinel, it'll keep on printing. So anytime you have a string in C++ or Java, C++ or C, also in other languages, although it's hidden in other languages, you don't see it. C++ and C is very clear. It says, a string means it's a character array and with a /0. Okay, it's there. Every string has that. So so that it can be printed as a string. Yeah. Okay. So all right. So that's what that function is going to do, and we'll write that later. Okay. So and then after the on line 17, go and hit enter. One more. Now what we want to do is what we can do is let's do a very, very modest first program. Okay, and we're going to change this a lot. Okay? So what we want to do is start this program with a let's say some character star greater than or something like that at the left edge of the screen, and we'll have it move slowly, right? 2 characters per second, bam, 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 like that, until it gets to the last character. Okay, but that's all it's going to do. So it's going to step one character on the same line. It's going to jump 80 times until it gets to the end. Is that okay? That's all, right? And that's all we're going to do. It's going to be so super duper simple. Okay, super duper simple. And then you can knock yourselves out by enhancing this to do lots and lots of cool things. Okay. So I put a comment there saying now we will print. Now we will change. Now we will change the screen. To change the screen contents periodically. Change repeatedly. Say repeatedly. No, change the screen contents repeatedly and print it out after each change, so that we get the flipbook effect. And draw it. Rather than saying print it out, say draw the screen. Draw and draw it after. Draw it after each change, so that we get a flipbook effect on our terminal. Yeah, okay, all right, good. So now we want to do our oh, by the way, why we need one more parameter for initialize screen, because we're using a native array and we're not using vectors. Okay, if we used vectors, we don't need this additional parameter. But remember what I told you last class about arrays. An array is just a memory address. So if you tell this function initialize screen and give it just the array, it says how big is the array? I don't know how big the array is. I can't, or it'll just keep doing it. So it can't work. You need to tell it, here's the array and here's how big the array is. So we need a second parameter there, and yeah, pass it screen size.
How do we know what functions need the array size? Is that all of them? Like all functions that use array?
Good question. Okay. Any function in which you need the array size. What are the places where you need an array size? You need an array size when you're iterating through the array and you need to know the end, right? That's the only time when you need to, or when you're indexing into the array and you want to make sure that you're not overstepping. Yeah. So times when you need to know the end of the array, you will know in your program. Or I haven't written any program in which you get past an array, but sometimes, very rarely, in which you get past an array, a naked array, a native array like that, which doesn't tell you how big it is. Very rare, right? In fact, if you get given a native array, you almost invariably will get given the size also in C and C++, unless you're using vectors, right? If you're using vectors, you don't need to pass that, because the caller could always say, hey, vector, what's your size? And it'll get the size. But if you're passing an array, there's no way to do that. Yeah?
Right. How about for loop?
Yeah, but the for loop has to have a termination condition, right? It needs to say for I equals 0, I less than something. What is that less than something?
Oh, I see. So you can just tell it to iterate through the loop, like to iterate through the array.
Yeah, unlike in Python,
Right.
where you could say, go through the, this list
Right.
until the list runs out. Because a Python list, a Java, all of these other languages, when you say a string or a list, it's actually more than just the native array, right? They have a lot of fluff built on top of that. So in fact, a Python list is actually a vector. It's not an array. It's a vector. It has other stuff inside of it. So it's heavy. It's heavier than C++. C++ is like bare metal, okay? If you go, it's bare metal. It's so clean that you can actually write code that can translate one-to-one to assembler. And so that is why really, really hardcore professional programmers, they just love C++. Even though they may be programming in the day jobs in other languages, they love C++, because when they know that, when I need to get to the bare metal and squeeze out every single machine cycle, which most programmers don't have to do, right? In our daily lives, most programmers out there, they don't need to be right down in the detail and saying, oh, I need to, use this spatula and get out this, tiny machine cycle. They don't do that because they trust the computer to do this. But most of all these top programmers, they know, right? They know if I need to do that, I can do it, right? C++. So that's the advantage. Okay, so here, what we'll do is, so we can start well, let's do a for loop, okay? Yeah, we'll do a for loop. Okay, we'll do a for size t I equals 0. In fact, it has to be size t because we're going to be comparing with screen size, yeah, size t. And then, so I is less than screen size, I plus plus. So on the next line, and in fact, in this for loop, we're going to have, multiple. That's good. That's what I was going to say. Yeah. So what we'll do first is let's draw a character on the screen at column I, right? So we'll say draw underscore char. These are functions we're going to write, right? We're going to write these functions now. Very simple, very simple. Okay? Draw char, and then open parentheses. And the first parameter is going to be the screen. The second parameter, unfortunately, again, because we're using arrays, it's got to be screen size. And you'll know why we have to pass a screen size, yeah? Screen size, comma, and then I, comma, and the character that we want to draw. What character do we want to draw? You want a star, or you want a greater than sign? This thing is going to just march, okay? It's going to march, bam, 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 like that. What do you want? Any character you want. Use a star. Okay, this is star. Okay, so star within. Oh, Andrew actually picked $. That's fine too, right? So and it's got to be within single quotes, right? Within single quotes, you say star. Okay, so and then we can put a comment on above that function call. Above that function call, we'll put a comment saying, you need a semicolon, by the way, remember to do that later. Okay, the comment should say, yeah, draw the character star on the screen at position I. Okay, that's what it's going to do. So that's what I mean. So, you know, we'll make it self-documenting so that it'll be easier for us to fill in the top comment later on. Okay, now a blank line after that. Blank line, one more blank line, and say, now sleep for half a second. Sleep for half a second. Comment, and say sleep for half a second. Sleep for half a second. Yeah. Okay. Now I think we found a way in which we can do this in on Windows, right? However, this machine here. Oh, you did that? This thread. But this machine you're programming on, Andrew, currently, this machine is not a Windows machine, right? Your machine is a Windows machine, but this browser is going to run code on a remote machine somewhere elsewhere in the world, right? That could be a Linux machine. So we'll actually use usleep, right? Say USLEP, USLEP, sleep, and then microsleep is microseconds. Okay, so how much is 0.5 seconds in microseconds? Is that 500,000 microseconds? So it'll be 0.5 milliseconds. So it'll be 500 milliseconds. So it's 0.5 seconds. Yeah, it's 500,000, isn't it? So this would be 500,000. Yeah, and when I write numbers, literal numbers like that, it's just a tip. And if you want, you can do this. When I write big numbers with lots of zeros, what I tend to do is I'll write that as 500 times 1,000. Okay, instead of 500,000. And the reason for that is because when an expert programmer, I'm not talking about newbies, okay? When expert programmers scan your code, they cannot waste the few milliseconds it's going to take for them to count in their minds how many zeros are there. Does that make sense? I don't know if you know. Yes, because think about it. When you're learning to drive, you can drive slowly, okay? But once you know how to drive and you need to drive from here to New York and you're going on, 85 or some super speed highway, right? You can't afford to do, stop and go. And every one of these bumps is going to be a real pain in the ass, literally, isn't it? So that's why these habits are good to pick up right away, so that you're writing code already that is set up for expert programmers, right? Eventually to look at and understand. All right, so that's what we're going to do. And then it goes back to the top of the line, right? So after you draw the character, we want to one more after the draw character, line 24. Hit enter on line 24. Yeah, right. There we want to draw that character on the screen. So we want to say show screen or show screen, or you can say draw screen, or whatever you want. Show screen is fine. Screen, and pass it the screen. And you don't have to pass a screen size at this point, because all that you'll know why. Okay, so and put a semicolon and put a comment on top of that. On top of that, you're basically going to say the following draw screen will print the contents of the existing screen on the terminal. It does, and on the next line you can say it doesn't need the screen size second parameter because it's just going to treat the screen as a /0 delimited string. Is everybody clear on what we're doing? Okay, if this is unclear, you should ask, like Mark just did. Just feel free to button anytime and say, hey, stop on, and just let me know, why we're doing that. Okay, so that's all we're going to do. Yeah, I think we're probably there already. This program will run. We'll just write those two functions and we're done. Okay, so
You
now
said /0, what type of screen? Or string?
Oh, delimited, 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 limited. It's a string. Okay, that's all. All right, so the functions, the two draw functions we have to right now are basically just one-liners, essentially. One-liners or two-liners. And thank you, Andrew, for cleaning up the code and all. That's very nice. Okay, so let's go right to the top of main and create the first function, draw screen. And can you copy the signature of draw screen from where you call it and paste it here so that we can just fill it in? Right, just triple click on the line and paste it there. Draw chart, draw chart. Yeah. All right. So yeah, and then we'll say that we'll make it return void. Okay, no return. Okay, just say void in front of draw chart and column zero, because it's a function declaration. We'll start at column 0.
Highlight all of it and press Shift Tab.
Oh, does it work in this online GDB thing? Hit tab? Oh, wow. Okay, so they actually intercept tab also. Cool. All right. All right. So so all this is going to do is, first, it is going to check if I is less than screen size. Okay, because if you got a screen that's only for 10 characters long, and then the calling function says, here's a character, I want you to put this character in position number 15 of the screen. What should it do? It can't do that, right? Because its screen is only 4 characters long, or in our case it's 80, and then the caller says, put the star in location 50, 100. Then no, I only have 80 spaces. I can't put it in 100. Yes. Okay, so that's why we need to check. So if, in fact, we'll do it better. We'll say if screen size is greater than or equal to screen, if I is greater than or equal to screen size, return false, and then we'll change the void to a false. Okay, so this function will return false if the character cannot be placed on screen. Okay, return false, and then because it's just that, it's an early return. One of the programming patterns, and it's a useful pattern, is that we don't have for false, bool, and then don't have braces, and then make that a one. Yeah, right. You don't have braces because it's an early return, so that people can get past that really quickly. Right now, we know that the character should live on the screen. You can actually go and draw that character on the screen, and you say screen square bracket I equals C, right? No. Screen square bracket I equals C, right? Now let's go and fix up the parameter in the function declaration line. Let's go and fix all the parameters, okay? So screen should be a character array, right? On line 11, screen should be a character array. So to say that to the function, you're going to put the word char in front of it, and then at the end, you're going to put square brackets. Empty square brackets. That tells the compiler that screen is a character array, right? Arrays are always passed by a reference. We'll come to passing by copy and reference later on. We'll do some experiments actually to find out, right? And the second thing, screen size is going to be size t, and make it now lowercase because it's not a constant here. It's being passed in as a parameter. It says screen size, or you can say max. Yeah, screen size. Screen size. Right, and then I should just be column number. Okay, so you say call underscore no or something like that. Call underscore no, and then, or you can say call num, right? And it's not num. Instead of no, you can say num. That's better, I think. And then that char should basically just be your character. You can call it a char C, right? Thank you. Yeah. Okay. Right, and I think you're missing a space before the size t call. There you go. Okay. All right. So and then we're on line 16 where you have screen square bracket I equals C. You need to fix that. Okay. Now before Andrew fixes that, can someone else? I know Andrew will fix it. Okay. Can someone else tell Andrew how to fix that line in light of the change that we just made to the function signature, right? Someone just call out. This is going to be 10 seconds of your time. Someone else, okay? Just say, hey, this is what you need to change. Not Adam, okay? Not Adam, because he's already, had a chance. Okay, someone else, and not Adam, not Andrew. Someone else tell Andrew how to fix that line 16, so that it is now correct. Take a chance, okay? It doesn't matter if you're wrong, okay? So if you're wrong, we'll just say, no, this is the way to do it, and that's fine. And oh, you changed it to a C, Andrew? Did you change it to a C? That's fine. Okay. All right. So why isn't nobody volunteering? It's variable.
I think there's no, can I see the rest of the program?
Sorry,
I guess you could say there's no loop,
there's no loop
or
here.
rather it's not set. That's what I
Yeah,
mean.
yeah.
It's
No
not
loop at
like
all.
you haven't set the variables.
Isn't there also the fact that this doesn't actually exist anymore? Yeah.
Great. Yeah, that's all. Yes, that's all the fix that we needed to do. Right now, you can just return true at the end. Thanks. Right? And you can return true at the very end. All right, that's this function. That's all. Now we can put a comment on top of the draw char function and say this function will set a particular pixel on the screen, but will not draw it. In fact, you know what? We should call it, we'll call it draw char. We'll set a pixel, but not actually draw it. But note that it won't draw it. No, but it will not draw it on the terminal. Yeah, it will not draw it, but won't draw it on the terminal. Okay. So now we're going to do the actual draw method. What was the other method we called it? We called it draw, did we? Draw screen.
Can I ask a quick question?
Yeah, absolutely.
Why are we keeping the next, so if you scroll back up, in the if, why are we keeping the screen size that constant in
yeah. We forgot to fix it. Thank you, Thomas. Thank you for picking it
that
up.
should be the okay.
Yeah. Oh, no, we just forgot.
Can I ask another question?
Yeah, totally. You don't have to ask permission. Don't ask permission, right? Both you and Thomas just don't ask. Can I ask? Okay, just button.
Okay, so it's a bool. So this kind of sentence is a Boolean, right? So if
sentence
you
is not
don't,
Boolean. No.
Oh, the draw character.
Yes.
What do you call it?
Method.
So yeah,
it's
go
a
ahead.
method.
Someone else.
So this thing, if you don't, so you put like return true at the end, but if you don't have that, will it just default to false? Or what will happen? Or will it have an error?
Do you want me to answer that, or does someone else want to correct?
Yeah, it'll just error.
One.
It's expecting some kind of Boolean output. So if the condition for the false statement is not met, then it doesn't know what to do, so it'll error.
So it will error. I see.
Mark also has a question. Maybe it's related. Mark?
Yeah, so if you want to return like two things, so would you just tell it tuple instead of
You
a
can't.
bool?
You can't. You cannot return two things in using a return statement. However, it is possible to return two things in a slightly different way. Okay, and I'll show you that. Right when we talk about passing parameters by reference, we can return any number of things. And when you get to objects, you can actually pack everything, all the things you want to return in one object, and return that one object. That's also possible.
Well,
okay, but right now using what we're doing, we can return two things.
Can you just return it as a tuple? Can you just return a tuple and then
There are no tuples in C++. There are no tuples in C. Let's put it that way. Okay, well, actually, there are.
Okay.
You can create tuples. There are no freebie tuples. Okay, the tuples not given to you by the operating system, by the compiler. Okay, you don't have any freebie structures like that.
Well,
In C++, you can.
Well, isn't a tuple like an array?
You can technically you can say, I'm going to use a convention that I'm going to use an array of 2 characters, and because I'm going to get 2 characters returned to me, basically that array gets returned to me, right? But
right,
if you think
so
about
you will write array instead of bool if you're expecting to return an array.
They have to be the same thing, like the same return type. Like you can't return 2 different types of things. You can't return like an int and a string. You have to, like, you could do a string and a string or an int and an int, but not an int and a string directly.
Right.
You can't. What Adam is saying is you can this function, the way we wrote it, is basically tied down. It can only return a bool. It can't return anything else.
Right.
If you want to return an array, you got to write another one. Yeah.
Yeah, you will.
Okay,
you will just write
that's what I
array,
thought you were asking.
right, instead of bool.
Yes, that's what I thought you were asking originally. Yes, you can use an array to get multiple values of the same type, right? Because arrays, you have to remember, array elements
Right.
are all of the same type. Yeah, you can't return a bool and a string. You got to return 2 strings or 2 bools. So you can technically use an array to get multiple values back from a function. Yeah, but there are cleaner ways to do that than that. So don't do that. I'll show you cleaner ways to do that. Yes.
Are there any structures that you can use different types?
Are there any what?
Structures that you can use different types of variables.
So
like-
just to answer your question, in C++, there is absolutely no structure. No, you cannot have a function return multiple types, right? A single function cannot return multiple types.
No,
the
not a
return type of
function.
the function is type.
A data structure that can store more than one type.
Yes, there is a data structure. I'm not in C, right? In C, there is a data structure called a union, right? And people don't even use unions now, I think, right? A union is a data structure that can pack multiple data types into the same space, so that you have 4 bytes. The same 4 bytes can be read as an integer, read as a character, the first byte alone, or you can, an array and things like that. You can do that, but we're not going to do that. Okay, it's a hacky way to do that. There are cleaner and nicer ways to return multiple things. Right, I'll show you very soon.
Right.
Yeah, but very good question. Okay, because that is what we want to know, right? We want to know, well, this is a simple function, but what if I have a function that returns multiple values? How do I do that? Okay, so I'll show you how to do that.
I have another question. So first thing first, is array the only data structure used commonly to store multiple elements in one, place?
No. This is main. This is already array is the first one we're doing. Just to get our feet wet. Yeah. So once you're comfortable with arrays, that's another reason why we need to get solid on this. Once you're comfortable with storing things and getting things back, right? Then you'll know any sophisticated data structure out there, you'll know how to approach it. Saying, well, I need to store stuff in it, I need to do stuff in it, I need to get stuff back, right? So that loop is what many students I find get confused about. And they say, well, you know what, it's a really complicated data structure because I don't know how to interact with it, because I don't know what to put in and what to get out, because that is the hard part. And so when I teach, I tell students usually, you have this big problem. Many people think that big problems are inscrutable. They can't do it, right? And they think they can't do it because there's just an easy step to get in the door, right? Once you get in the door, everything is easy. But they think that opening the door is hard. So I say, when I teach, these things, I say, forget about the hard stuff, right? Don't look at the hard stuff and be intimidated and say, I'm never going to be able to do that. So just do, and this is the bit that we need to know is, it's an array is one of the most incredible data structures because it can be as small as you want and it can be as big as you want. It can occupy the entire RAM, right? If you have terabytes of memory, you can have an array that occupies terabytes of memory. And you can access every one of those elements like that, bam, bam, bam. So super duper powerful, very versatile and useful data structure. And at the same time, the array gets you, and because it's easy to use, it will get you accustomed, right? So that's getting used to is the hardest thing, I think, right? Because in fact, I think there is a story of von Neumann. Did you know von Neumann is one of the forerunners of computer science? In fact, the architecture of computing that we use today is called the von Neumann architecture, because von Neumann was one of the people who was pioneered the modern computer, saying, well, this is the way in which you can code things, and the Turing machine can be, the instructions can be executed. So it's called von Neumann architecture. So von Neumann he was a brilliant mathematician, right? And computer scientist. I was in the East Coast, I think. And then one day, he wanted to understand something with tensor calculus. Okay, tensor calculus. Basically, tensor calculus is a more sophisticated form of vector calculus, which you will be learning, right? If you do calculus, differential equations, and then vector calculus. Obviously, I think there's math 1D at Foothill, right? Vector calculus, where you do surfaces and gradients and all, which is actually super duper useful in machine learning, right? When you go to machine learning, you construct the inference surface right? Saying, well, this is the surface of the problem, and our solution is to find the least point. That's the least error that the customer will face. Okay, so this is the surface of all the possible errors that customers could face, all values, the errors, right? But so we need to find an algorithm that will traverse the surface and find the lowest point, because that point, those parameters are what we want to use in the finished product. Okay, so you employ machine learning to find out what is the least point in the surface. How do you find the least point? Now, we actually did that I think in a previous class. It's called gradient descent, all right? So, and if you're going to do machine learning and data engineering later on, this is probably they'll teach you this in the first week of machine learning. It's called gradient descent. It's very simple, right? And it goes back to a very ages, right? I'm pretty sure in ancient China, they were doing something like this too. You take a parabola, right? And if you want to find the minimum of the parabola, what do you do? Someone tell me, how do you find the minimum of a curve, a parabola?
Take the derivative.
Yes,
and then,
right.
Yeah.
And set it to 0 and solve. Yes. Right, so if you take the derivative, so that is an analytical way. An analytical way in which you have the equation of the parabola or equation of the curve, differentiate it and take the derivative, set it to 0, solve for x, and that is where you'll find the minimum or maximum, right? Or an inflection point, but just say minimum. So minimum. However, if you didn't have the luxury of mathematical tools, or if the equation of the curve was not simple like a parabola, it was like a complex equation, right? Like that, okay? And you still needed to find the minimum. How can you do that? Right? Because already differentiating functions that you can see on paper sometimes get really hairy. Yes, you've done calculus. Some differentiation problems are really hard, aren't they? So you have some surfaces that three-dimensional surfaces that go all over the place, warped like that, and you're saying differentiate that and set it to 0 and find out where the minimum of that is. It's really hard, but there is a way in which you can find out, not accurately, but you can get a good guess of where the minimum is. And let's start with the parabola, and we will actually do that in a later class. Okay, so if you have a parabola, you don't know where the minimum is, find any point on the parabola and put your finger there and say, and first make a guess. This is a computational way of doing this, not a mathematical. This is mathematical in the sense that you can prove that it converges, but computation. I think I'm so glad someone asked this question and you can touch upon this topic, because this shows you very clearly the difference between an analytical solution to a problem and a computational solution to the same problem. Same problem solved analytically, differentiate, set to 0, got value, bam, like that. Yes. Now you can't do that because the equation is too complex. You do the iterative solution, which is computational, not guaranteed to give you the right answer, but many, for reasonable surfaces, very likely that you'll get the right answer. So what you do is you have the parabola, pick any random point that you can do. You don't need math for that. You put your finger anywhere on the parabola. Now at that point, find the slope of the parabola. You can always find the slope of the parabola, because if you have a point, all you need to do is go a little bit to that side and a little bit to the side and get the y values, because you have the shape of the parabola, right? So you can say, so this is the rice and this is a run. So divide the rice by the run, you get the slope. Yes, you can, given any point on a curve, you can change x by a little bit and y by a little bit and plug in the values, find out the values, y2 minus y1 over x2 minus x1, that's your slope. Yeah. So you can find the slope at any given point on the parabola. Now take a look at the sign of the slope. Okay. Now, if the parabola is like this, and you know that the minimum is on this side. If the parabola is like this, the minimum is that side. Okay. So if the slope is positive, this is a negative slope. Okay. This is a negative slope. I don't know. Yeah. Negative slope, that x needs to be incremented. You need to go to the right. If it's positive, that x needs to be decremented. And provided the increment and decrement steps are small enough, right? So you don't overshoot, right? Because that's the danger of doing that iterative approach, is that, well, you close, but you need to move to the right, you overshoot, go there. Now you find you need to go to the left, and you could end up doing that for infinite times, right? So you get lost. So, but if you make the step sufficiently small, that's called the learning step, right? In literature, you'll see that as eta, right? The Greek letter eta. The learning step is sufficiently small, you can be very confident that you'll converge, right? Slowly, step by step, you'll be moving your x and you get to the minimum. So how cool is that? Okay, iteratively, you got to the minimum of the parabola without using mathematical knowledge. So there's two solutions to the exact same problem. How do we get started talking about that? Okay. So Neumann, von Neumann wanted to know so I wanted to understand tensor calculus, okay? Because he was working on some problem and he wanted to, and that time, I think, oh, actually, I'm so sorry. So Einstein, right? Einstein was working on general relativity, right? His theory of general relativity. And in order to develop that theory, he needed to model space-time as this complex surface and, you know, and model it. And for that, he needed to use tensor calculus. That's the story, I think. I might be wrong, okay? So, and at that time, the leading expert in tensor calculus was von Neumann. And I think he was at Princeton or some other university, okay? So Einstein said, I want to learn about tensor calculus. Let me go to von Neumann. And he spent some time with von Neumann, and von Neumann taught Einstein tensor calculus. Now, at the end of the lesson, Einstein said to von Neumann, apparently, right? Professor Neumann, thank you for teaching me. I understand. I know I can see how it works, and I can plug in the values, and I can get everything. I have what it takes to, you know, finish up my theory. But I'm afraid I don't understand. I don't understand tensor calculus yet, right? I can get it to work, but I don't understand it. And so von Neumann told Einstein, apparently, young man, so apparently, you know, he was much older than Einstein at that time. Young man, in mathematics, you don't understand things, you only get used to them. Okay, so like that. In this case, of course, everything is simple. We can understand most of it anyway, right? So I think that's basically it. Yeah, we have a draw screen, right? Draw screen is very, very simple. All you're going to do here is simply see out the screen in draw screen on line 24.
Andrew's
Andrew's currently in the
He went to
bathroom.
the bathroom.
Yeah, he said it in the chat.
Oh, he said something in the chat.
Mhm.
Oh, he'll
He's
be
going
back.
to the bathroom.
Oh, yeah, okay.
Can
You
I ask
can
another
tell him that
question?
later. Yeah,
I
sure.
have another question. So I see that Andrew uses void here. What exactly is void, and when do you use void?
So you see,
get that
I would
it's
say
draw
no
chart.
return type.
What is it?
There's
So-
no return type.
It's no return, but like
It's not returning anything.
so it's
If you
running
write a
a
function,
program
yeah.
that doesn't return
It's just running
anything.
a procedure. Yeah.
Oh, when do I use it?
So sometimes you may write functions like now we're going to do a draw screen function, which we're confident will work. We don't need, so like you have something to get done and you say, do this, but you don't have to tell me, you don't have to come back and tell me whether you succeeded or not, because I just need to get done and I'm confident you'll do it. Okay. So in that case, do you tell that person, do it and come and report to me, right? So there's two things, right? You can say, there's a task, do it and come and report to me whether you're done. Or to another person, you could say, do this, you don't need to report to me because, you know, they just need to be done. I'm confident you can do it. Two things. Yeah. So the second kind of thing is void, and the first thing is return value. Does that make sense?
Yeah, but I can use something that returns to me to do the same thing.
You can,
It's just
if you
that
want.
void. Yeah, it's just that we are like confident enough that this thing will work, and so it's
Yes.
just something that runs in the background, and you know it does it. I
Yes.
see. Thank you.
Basically, if it doesn't work, it's going to crash the program like that. You know, you know
Okay.
it's going to work. All right. So here you simply just do a cout and a shift left shift the screen, and at the end of that, you're simply going to print a /r character. Left shift /r left shift, and then /r within single quotes. That's it. And then since we are printing a /r, I think it put 2 single quotes. It's an autocomplete or something like that, right? So since we're printing a /r, we don't know if the system is going to flush the output stream, because, you know, end_l will flush, and then /n will also flush, but we don't know if /r will flush. So we'll explicitly flush on the next line, and on the next line you say cout.flush. You can put a comment on that line too. Open, close, open, close, open, close. And put a comment there on that line saying explicit flush because we're not sure if /r will trigger a flush event. Will trigger a flush event. Okay, that's all. I believe that this program will actually work, and we don't even need to go to your terminal on Windows, because we're using microsleep on a remote computer. This may actually just work right off the bat on this terminal, right? Inside of the browser. If you run it now, I think my famous last words, right? So I think it'll work. It'll print this line, and then no, Adam is shaking his head. Something is wrong. Okay, what's wrong, Adam?
Do you need, I guess I can say, but I almost don't want to spoil it because we still got.
Oh, wait a sec. Okay. Well, don't spoil it. Okay. We will scan the program and we'll try and find out. Okay. I haven't found out, by the way. I haven't found out if it's going to work or not. So I need to
I
scan
can't
it.
tell because this is using a bunch of things that I don't personally fully understand.
I'm sorry?
You can just do, I don't know personally, this is using a bunch of things I don't understand. Like you can just do C out and then an array.
I see.
Yeah.
Is that why Adam? Is that why you said it may not work? All right.
No,
So let me
this is
find
just
out
stuff that I don't understand. So I can't figure out why, but we can run it and see.
Initialize. Oh, we haven't written initialize screen. We haven't finished initialize screen yet. Is that the reason?
And we haven't included usleep or whatever the.
Oh
thing
yeah.
for
Okay.
usleep is.
Thank you. I think usleep comes from one of you can Google and find out. I think it comes from unistd.h or something like that. Okay, but let's initialize. Let's write initialize screen. Okay, initialize screen. That function, whatever that function was. Void is good enough for that. And then you get past the screen and then the screen size. You got to get past the screen and the screen size. Yeah. So you can say char, screen, square brackets, comma, screen size. Yeah, okay. Now in here, all you're going to do is for size t I equals 0 to screen size, you're going to just fill it all with blank spaces. So for size t I equals 0 to screen size less than screen size, fill it all with blank spaces. Screen square bracket I.
So I think it's unistd.h for Linux and windows.h with a capital W for Windows.
I see.
Is it on this
hash
online thing then?
unistd.h. unistd.h. Okay. Now is your initialize done? Initialize finished? Equals space within quotes, single quotes. Okay. Okay. And you can get rid of the braces because it's just that line. And then on the next line after the for loop, we're going to say put the termination character. So you're going to say screen square bracket, screen square bracket, screen size -1. That's the last character. Yeah. Screen size -1 inside of that. Equals \0 within single quotes. And you can put a comment on top of this line saying \0 is exactly the same as the numerical value 0. Okay. And then why so, and you can say why do we use this instead of actual 0? You can discuss that in the forum. You can look it up and discuss in the forum. Okay. Why do we use this instead of actually using 0? Look it up and discuss. Yeah, you can put a comment there. So if someone is reading this program, they'll know that they need to. So extend that comment saying dash look it up and discuss on the sub. Look up and discuss, right? Look up and discuss. Yeah, look it up and discuss on the sub. Yeah. All right. So I think that's it. This should potentially work. I think it should work. In my mind, it works anyway. So we should be able to run it now, and hopefully it will work. Okay. If not, we'll find out very soon, and then we can fix it. All right. Okay. All right. Okay. Kill it. So there is a bug. There is a bug. We didn't clear the screen before. We didn't clear the screen before drawing the next star. Okay. So let's go. We'll write one more function. We'll say. In fact, we can initialize the screen for now, because clear is going to be essentially the same as initialize screen. So should we just change the name initialize screen to clear screen? Yeah, just change the name to from initialize screen to clear screen. Clear screen. And then and then inside of the loop, before you draw each character, clear the screen also. Yeah, now you need the braces. No, not there. No, not there, not there. Just before you draw. Just before you draw, you clear and then draw. That's all. This you can leave as before.
How do we clear?
No. Get rid of the blank line. Get rid of the blank line. Right? And oh, gee, you need to put a. Oh, wait a sec. A clear screen does that. Not there. Okay, so you need to go to your main. You need to go to your main. And then here, after you draw the character, no, before you draw the character, clear the screen and then draw the character.
How do we do that?
The same way as the function, as the one above the for loop. And actually, we probably don't even need the one above the for loop, because this one is just going to run at the start of the loop anyways.
Yes.
So we're just going to clear it twice.
Thank you. All right, so get rid of that one. And then you can transfer the comment. Yeah, you can transfer that. Don't kill the comment, and transfer the comment to the second invocation, and then you can get rid of the call alone. Yeah. Okay, and you can get rid of the call on 40. You can get rid of 47 and 48. That's what Adam was saying. Okay. All right. Now, if you run it, I think you'll see a star move, very slowly like that. If you run it now.
Ooh.
Yeah. Okay. I think this is actually a flip book, right? It's a flip book. It's just doing it on the same line. Now, this is the effect we were going for the other day when we're trying to do this race with two people starting on the two ends. We'll have those characters going towards each other, and the first person to hit the middle is a winner. Okay, and that'll actually be a really cool game. If you want to do it in your spare time outside of class, I'm happy to have another Zoom session and guide you through that. Not during regular class, because that'll be really cool. Because you can write that as a 2-player game, right? 2 players on a single computer. Okay, and they're sitting and they're L and K. They're hitting LK. Left players, right player is hitting LK rapidly, and the right player is hitting A and S. These 2 fingers, bam, 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 and whoever hits it faster gets the star to move faster. Okay, and we can do that really quickly, and it's a really cool game, right? You can play the game anywhere, even via a browser. So anyway,
Yeah, something at the end. Why did it just stop at the end there?
Oh yeah. Okay. So what happened there was that it went all the way to the end, and it also overwrote that /0. And so there's a corner case. That's called a corner case bug. It's a bug. It's a corner case where you went all the way and then also overwrote the /0. And when the /0 is gone, the cout is going to print everything, right? It's not going to stop at the /0. And beyond the /0, there's junk, and it printed junk. So it printed the /0. And so if you want to debug this, all what we need to do is I less than screen size, I plus, and char screen size +1. Oh yeah, of course. You know what? We forgot to put what, our initialize function had the /0 at the end, but we took it out and made that clear. Where's our clear? Where's the clear? Do we have a clear? Can you show the clear screen method? The clear screen method. Where's a clear screen? Oh, clear screen does put a /0 at the end, and it's still clear screen does put a /0 at
Because
the
we
end.
draw the char after we clear it, so it doesn't matter if it's cleared before. It could just immediately
No, but I'm
override
saying
anyway.
it should not have put anything in that location in screen size -1. Why did it put something in screen size -1? It shouldn't have put something there. Go to the draw character method. Where's the draw chart? Yeah, I can tell you, it shouldn't be greater than or equal to. It should be just be greater than. No, it should be. No, it's greater than or equal to. No, if it's greater than or equal to, return false. So it should not have put anything in 80. No, that's correct. So that means it should not have put anything in 80. Yes.
Means it should not.
It should return
placed-
false. It shouldn't have put anything in column 80. Column 80 is, 80, the 81st element of the array. So it would not have put anything in the 81st element.
Wait,
And-
But it would put something in the 80th element, though.
No, it would it would not have put
It's
anything
equal
in.
to return
Yeah, it
false.
can put something in the 80th element. That's fine.
Right, but
Why-
it says
why should
it's the 80th element, but it's the 79th index. So it needs to be,
I'm
you need
sorry?
to remove so it was the 80th item in the array, but it's the 79th index. So you need to remove the equals. So it's just greater than. Right?
I don't think that'll. No, that I don't think that's.
No, just screen size -1. You want it,
Well, same thing.
needed
Yeah.
to go, no, that greater than goes the other direction, minus, or like screen size -1 goes.
You do need to have screen size
No.
-1 for sure. Yes. You need to have
Yeah,
screen
I'm
size
just-
-1.
Okay.
Oh, we didn't have screen size -1 before? Before it wasn't screen size -1? Oh, yes. It should be
only
screen size
part
-1.
where-
I'm sorry. Should be screen size
No, I
-1.
meant in,
Because, no, here
in
it should
draw
be screen size
character.
-1.
Right here.
-1.
Yeah, I was just saying you could have done the same thing by removing the equal sign, just saying greater than.
No,
Oh,
that would have
no,
gone,
how would that work?
screen size -1 would do greater than equal to 80. If you just
greater than
remove the
equal to
equal
79.
sign, it would be greater than 81.
Screen size -1 is 79, isn't it?
No, because we add one. Oh wait, because it's not the. Sorry, I was thinking of the size of the array. Oh, that's another issue, right? Aren't we supposed to put it at the screen size because we increased the size of the array by 1 when
Yeah, we know.
created it?
Let's do it the right way. Change that. If in your main, it should just be 80. Don't do that +1 there in your main. Screen size is 80,
Fine.
and we know that the 80th character is, index 79 is
Okay.
your /0. That should do it. That's cleaner, isn't it? Do you agree? Does everybody agree this is cleaner?
Get rid of this.
So if you run it now, you should get the funny character.
That's probably
You
what
should
it
have
was.
No, you should have a -1 there. You should have a -1 there.
Yeah,
okay.
have a -1 there. Those two things probably were the main bugs.
Why we want string size to be 81 before?
Oh, because previously I was thinking 80 characters means you can actually see 80 characters, and then the 81st character will be a /0. That's what I was thinking before, right? But then that resulted in messy code like we did. And so we said, just now, like a few seconds ago, we said, let's not mess with that. We'll just say our screen size is 80. That means only 79 are visible. The 80th character is not going to be visible. And that's easier. Yeah. So we made that decision a few seconds ago. That's why. Does that make sense? Now, if you run it, you won't get the funny character at the end. Oh, it is moving. It is
Been
moving.
running it. It printed that like one line first with a star at the front and star at the end.
Oh, it did. It did that.
Yeah, the one right above it.
Oh, then let's wait and see what happens now. No, run it again, run again, run again.
It didn't do the extra characters, but it did that line beforehand. Oh, when
No, I
this
think that
time it
was
did not.
probably a leftover. Yeah, it was leftover from the previous run or something.
Okay. Nice.
Hey, it's kind of cool, isn't it?
Yeah.
Okay, great, great. So you want to take this to the next level now? So we'll do a few more things. Yeah.
Okay.
But we won't do a few more things until everybody is happy with that. Okay, so I'm not gonna. If you want to play, how about this? What time is it now? Oh, we got. How about 5 minutes? Okay, 5 minutes for you guys to just pour over this program together. Okay, Andrew will scroll up and down. Hopefully, yeah. Is that okay for everybody to view the program? Because people may have questions in different parts. If you guys can look over this program and say, hey, what's going on, and so on and so forth. 5 minutes for that. And after that, there's only 2 more concepts that I want to introduce, right? So static variables and passing by copy and reference. Okay, so I just need to talk about that. No, we need to do a couple of experiments. Okay, all right. So are you guys ready? Are you guys ready to do the experiments with copy and reference? In fact, what we'll do is why don't we stop this program here so that we don't extend this anymore? Because I can see already there's the scope for extending this program to do cool things like games, 2 people running towards each other, or displaying with effect, which we will do display with effect next class, where you you create a class saying, I want a string saying hooray, but I don't want to slap hooray on the screen. I want hooray with stars floating towards it, or I want hooray with the letters flying from the left and right, like in Microsoft PowerPoint, HOORA, like this. Bam! They come and get together into that word in the middle. This is displaying with effect rather than just display, right? So all of that can be done. Anything, any animation you can do in one line, you can now do, because we know how to do one-line animations. Yes, without using any sophisticated graphics, we know how to do one-line animations. And later on, that's what I was saying in 2B, right? But I'll show you how to do just with characters. I can do 2D animations too. That's also possible. Okay, this is using something called ANSI codes, ANSI codes. You can Google it if you want. But using ANSI codes, you can position your cursor anywhere on the screen, right? And so you can do 3D graphics also just using ASCII. And we can do that in 2B if you guys are going to do that. But other than that, if you're happy with this, I can leave this program alone for now, and we can move on to another person picking up the screen, and we can do 2 small experiments, which will show you the effect of passing by value and passing by reference. Okay, and which will also touch upon this thing that Mark raised before. Where's Mark? Is Mark here? Oh, there you are. Okay, so saying what do you do if you want to pass return 2 values, right? We know how to pass 2 values, but do you know how to return 2 values from a function? And that will also be touched upon, right? So we can talk about that. If you guys are happy with this program, we can just freeze it right here, and then thank you, Andrew. Right, Andrew, you were very helpful, and also staying in step, and also in the right pace for all of the students and us. So I think it worked out nicely. Was this useful? This little exercise that Andrew and I did, was this useful for everybody? Yeah. Okay, we implemented a function.
Felt quite useful for me.
I'm sorry, someone said something, I couldn't quite get it.
But this was a very useful program for me.
Oh, I see. All right. Thank you, Andrew. Hey, actually, you know what? The mask you're wearing is actually is not very sound friendly, I think, because it's very muffled when I hear you. Yeah, but there are other masks with thinner fabric. Yeah, it's okay. But I'm just saying, there's thinner fabric masks. I found someone gave me a really expensive mask a while ago, and I found the expensive masks are really thick, and the voice is harder to get, go through the expensive, but thinner ones are really cool. You can actually speak through them. Okay, all right, cool.
I will stop sharing and post this on the Reddit.
Yeah, totally. Now, how about someone else now? Someone else who wants to take the screen? We are going to do a few small experiments. Okay, small experiments, because we only have like 10 minutes or 20 minutes left. Do small experiments that will demonstrate the effect of passing by parameter and value. And that's all you need to know for the midterm, other than arrays. So just brush up on these things and get really, really solid. Okay, really, really solid on this. because this will serve you no end for the second half of the course and also for 2B. How many of you are planning to do 2B? Because right now we're even thinking whether I should offer a 2B. Thanks. Yeah. So because the enrollment and the strength in my 2B is low, so I don't know if we'll offer my section. So if you want to do my 2B, you'll get credit for all the blue quests. But if it's not offered next quarter, I don't know what we'll do. You'll have to hang on to your. Oh, you can do someone else's 2B. It'll be easier, I think. But you won't get credit for the blue quests. And the question, you'll still get to do quests if you do my 2B. But if I offer it again, it'll be fun. And hopefully all of you will enroll in it. And if you're solid on this, you'll find 2B a great deal of fun. Okay. If you're not solid on this, 2B will not be fun at all. It'll be very, very exhausting, and lots of students will just drop who are not prepared for it. Okay. So how about someone else pick up the screen? We'll write a couple of functions now, and they will pass by parameter and value, and we're just going to be, these are not going to be fun projects, but these will be experiments that actually very clearly set out what's going to happen if you do this. So you know in your mind, this is what's going to happen. Mark, do you want to take the screen? Mark, you've never taken the screen before, right?
Mm-hmm.
Yeah, okay. So you can,
Yeah.
in fact, because we're going to be doing by the double parameter, double value return and all, you'll find it very useful.
Yeah, I'm just gonna open Visual Studio first. 1 second. Sign in.
It doesn't have to be Visual Studio, by the way. You can just do it just like online, because we don't need.
Sure. So what would you recommend then?
Whatever he was using. I think it was onlinegdb.com. Onlinegdb.com.
Online G.
I thought we were
Online,
gonna
C++
terminate a relationship.
compiler.
Online C++ compiler.
Yeah,
Okay, I
I
see
just
it,
searched
I
up
see it.
that. I got that.
Mm-hmm.
And by the way, while Mark is
Yeah.
setting up all of these, everybody else, right? Ashley, you haven't taken the screen before. Almost everybody else has had a chance. Wow, almost. Oh, Leonardo, you haven't had a chance.
I don't think I have.
Who was that?
Will,
Will, you did?
yeah. No,
some reason
I've
I
like
thought you
helped
had.
with things, but I haven't actually. Yeah.
Oh, okay, cool. All right, no worries. Okay, so in fact, it sounds like you have a bit of experience already with some other language. So you should save yourself for week 7 or 8, because we'll do some bigger projects now. Yeah. Okay, cool.
Sounds good.
All right, so let's run a couple of experiments, and so put the date on top and say, today's code. We're going to experiment with parameter passing by reference and copy.
Experiment. Say again.
Experiment with passing parameters by copy and reference. By the way, you have a 1440 wide screen, right? Can you get to non-white format, because the font is really, really tiny for me. I can't read anything.
Is there a way to make it like full screen?
I actually hit Control plus.
Control plus.
More. Yeah, okay. No, I want one less. No, that's too big. That's 4 or 5 less,
Okay.
I think.
It's weird that they don't have like, you can make a big screen. That's weird.
Yeah, no, there is. We don't know, I think, because some other student pointed out how you can make it bigger. Oh yeah, click the lightning on online GDB there. Click the lightning next to online GDB, lightning icon. Okay, that'll make it slightly bigger. Click it.
Mm-hmm.
Oh, nothing happened.
No, I think it just loads
the
back.
arrow on the left, yeah.
Yeah, it's the arrow next to the orange button where it says 182K on your left side. And then there's a little arrow to the left. Go down a bit. Go to the right a bit with your mouse,
like
and there's
that?
an arrow right. No, go to the right, the button right to the right, sort of. There you go. Click that.
Oh, I see. Cool. It was right there. We didn't see it. Okay.
Yeah, thank you.
All right. We put a lot of stuff in there. Yeah. Okay, cool. Get rid of that.
With passing.
Okay.
So, is that okay?
Oh,
With
passing
did I
parameters
miss
by
something?
copy and reference.
Mm-hmm.
All right. So put the standard template in, hash include, and your main with an empty body and return, and then we'll take it from there. I don't know, Andrew, before you post your code on Reddit, you have to edit the comment at the top saying, you know, we're going to play with passing by reference and copy. We didn't do that in that program. We're doing it here, right? So get rid of that comment saying you're not doing it.
Gotcha.
Right. Cool. So all right, put your main there using namespace, and then put main.
Wait, I think I messed something up. It's not include namespace, right? It's using namespace.
Semicolon. Yeah, using, not include. Using namespace, and above using namespace, say hash include IOStream, and then a blank line after that.
Include what again?
IOStream within angle brackets. Angle bracket IOStream. IOSTREAM. Stream.
So stream
or stream STREAM.
Like that.
Okay, yeah. Yeah. And
What
line
does
after
that do
would be
again?
nice.
That includes specific. Specific include.
Yeah, sure. Hit enter there. I'll tell you. Hit enter after that. Just put a blank line. IOStream is basically an include file that will get included inside your program, which contains the declarations of all of the common things that the C++ environment gives you, like cout, endl, all these things already, and anything to do with IO, input and output. All of those things are already pre-built for you, and they're provided in the IO library. And IOStream.
So we will use that for most of them, for most of the programs, and not all of them.
For most of the programs, no, not for most of the programs. Actually, that's wrong. Okay, all the programs that talk to the user will use this, right? You may write lots of programs that don't talk to the user. They don't need this.
I see.
Or talk to files.
So is the main? What does the main return, or like what do we expect?
Oh, by the way, you need a semicolon after std.
Oh, right.
Yeah. Okay. Enter, and then int main.
Okay.
And then open close parentheses. Open close. Yeah. And then braces, and then return 0 at the end.
Wait. So do I need to know?
No, none of that. Just just open close. That's enough.
Okay.
Close. Yeah. A space and brace. Yeah. And a space before the brace will be nice. Cool. All right. So now what we'll do in main is declare a variable called n, right? Int n. Yeah, n equals 10. Let's say n equals 10. Okay. Now what we'll do is a blank line, and then blank line, and I put a comment there saying pass n to a function that will increment it. Pass n by value to a function that will increment it. Okay. Now before this comment, say cout n and /n. So before, on next blank line there, blank line. Enter.
This blank line?
Enter. Hit enter. Yeah, hit enter.
Okay.
Yeah, new one. Sorry, that's what I meant. No, before the pass, before that comment.
Oh,
sorry.
So here, this
Enter
line.
Yeah, one more enter there. One more enter. You say cout left shift, and within quotes you say n equals.
Wait, cout left shift. You mean like
left shift? Yeah,
like
left
this?
shift. And then within quotes you say n equals. N equals, and then outside of the quotes we say left shift n, and then end out. Right, and then one more cout there on the next line, and you say cout attempting to passing n by value, right? Passing n by value to incrementer, to a function, to incrementing function. Yeah, incrementing. That's fine. To incrementing function, and then within parentheses you can say this is not going to work. This is not going to work, right? Within parentheses say this will not work. Okay, and then close parentheses and a space before the opening parentheses, because this is not a function call, right? So, okay. All right. So now on the next line after the comment, yeah, good. After the comment.
Oh, after the comment.
After the comment, you can say function. No, you can say increment function incrementing function underscore wrong or something like that. You got to put come up with a name. Okay, the name has to somehow imply that it is going to increment the value, but it is the wrong function. Okay, it's got an error.
Is there a word called incrementation?
Yeah, who cares? I get the meaning though. Everybody gets the meaning, I think. So it looks good to me. Incrementation. Yeah, I don't know. You can. Yeah, we should look it up later, but it's certainly implementation. Okay, all right. So pass n.
Wait, did we define wrong? I don't think we defined.
No, we're going to. Yeah.
Wait, can you call the function before you define it?
Well, certainly. We can't call it. We can write the call. We're not calling it. We're just writing down the call. Right.
I'm saying if you have the call before the function definition, it will still call the function, because I'm pretty sure when the code runs, it runs everything at once, right?
Yeah. Okay. All right. So very good question, Mark. Okay. Generally speaking, it should run, but the compiler, if you have the function definition later, right, and the compiler doesn't know that function exists, the compiler will say, "Hey, you're calling a function. I don't know what that function is. I'm not going to compile it." The compiler won't compile your program. However, if you know for sure that the function exists somewhere, right, either later on in the same file or in a different file, you can tell the compiler, "Hey, compiler, don't crap out, okay, because you found a function that doesn't exist. This function exists somewhere else, and here is the definition of the function." And you can tell the compiler, "This is what the function looks like, but this is not the body of the function." So you don't need the whole function body, just the signature. That's all the function needs, the compiler needs. So in order to do that, let's do that. Okay. So go right to the top after using namespace standard, after using hit enter after using hit enter, and then one more. Put a comment there saying, say forward declaration, FORWARD, forward declaration of a function. And on the next line, you say, in comments again, you say, this is needed if a function is defined after it is called, okay, in the same file. Called in the same file, okay? Or in a different file too, or in a different file. You say, or in a different file, or in a different file.
Is it okay that the sentence begins on a new line? It's just because I don't want to pass this line, right? Because you don't want to make the line too long.
You can break up the lines.
Wow. Yeah.
You can play with the aesthetics later before you post it on Reddit. Yeah. You can clean it up. You can clean it up as much to your heart's content before you post it. So on the next line, you're going to say, wrong incrementation. And you can say it's a void wrong incrementation. Yeah. And it's in the beginning, you can say void. And then at the end, you're going to say open parentheses, int n. And then at the end, you're just going to say semicolon, no braces or anything. Right. And after the semicolon, put a comment saying this is a declaration for the compiler, not the actual function body. Okay. This is a declaration for the compiler, not the actual function body. Okay. That means now the compiler will be happy. Even if it doesn't see the function before the main, the compiler won't complain. Now let's define the function, but we'll define it after main, right? Go to the end of the file.
We need that because the compiler at least needs to know what parameters it takes, because otherwise it's like, it needs to make sure. Okay, I see.
Yeah.
Okay.
And the reason the compiler needs to know is for our own good. Okay, that's the only reason. The compiler needs to know that so that it can have your back. When you accidentally code a function, if you accidentally call a function with only 3 parameters, but it takes 4 parameters, right? The compiler can do its job and compile it, and the code will crash when you run it. So you don't want it to crash. So you tell the compiler, just go over my code and make sure I haven't made any silly mistakes. That will help it. Yeah, that's the only reason we do that. Okay. So now let's go to the end of the file and define the function, right? End of the file. Oh, you need a semicolon after the call. You need semicolon after the call.
Oh, right.
And after the call, take the cout n equals, that line 14, copy that entire line and put it after that. Now, before the n equals, within the quotes, you say after the wrong incrementation n equals, right? After wrong incrementation n equals, after wrong incrementation comma. Okay, that's all. Okay, now let's go to the end after the brace and we'll define the function. Now you can just define that function. There is a void, wrong incrementation, int n. And now we'll do the body of the function.
Void, let me just copy it.
Yeah.
Just a quick
Right.
question. We're saying n equals, but we're not actually using n then after. Should
Oh yeah,
Like
yeah,
we-
okay. We have to print
yeah,
n. Yeah, we have
yeah.
to. Who said that? Yeah, thank you, thank you. We have to put n on line 18, line 18, line 18. No, no, no. You need a blank line there. Put a blank line back. Put the blank line back. Yeah, he's saying before the endl on line 18, you also need to shift n, left shift n, and then endl on line
also
18.
on 14.
On 14 also.
Left
Oh
shift
yeah,
n.
yeah.
I'm not
Totally
sure.
forgot.
I'm not sure what you mean. Like include n
oh,
equals and then n.
No, no, no.
Is that what you
Just
mean?
say n. Just say n. And then one more left shift after that. One more left shift. Space left shift, and now endl. Now you need to do the same thing on the other one too.
Oh, so it will print n. Okay, yeah. Yeah, I was also kind of confused why we didn't include it. I
Yeah.
thought like the
Yeah,
function
you
will include
basically
it,
just
but-
butt in, okay? Because sometimes I just say wrong code. I haven't coded this before. I'm just coding off the top of my head. So
wait,
obviously I'm going to be
wait.
mistaken.
Don't we need to do something like this?
No, no,
Not
because it's
n,
void. It doesn't
but
return
like-
anything.
Oh, right. It just prints.
Yeah.
Okay.
No,
okay,
incrementation
right.
doesn't do anything. Incrementation is just going to increment it. It's not going to print anything. Increment is just going to change the value of n. Yes.
Oh, okay, okay, right.
Now here, all you're going to do is just change the value n plus plus. That's it. Semicolon. That's it. That's the only function. That's the only thing this thing does. Now, if you run it, n is not going to change because it's wrong, isn't it? Because it's going to say 10, and after incrementation also, it's going to be 10. Run it, it'll say 10, 10 two times. What is it? Oh, can you fix that?
Wait, what?
You
Line?
put a
I can't see.
semicolon on line 22.
Oh, yeah.
There shouldn't be a semicolon.
yeah.
Okay.
Right.
So if you run it, it'll just print 2 times. Yeah.
Mhm.
Now, suppose you want to make it do the right thing. What we want to do is create another function called right incrementation, right? Right incrementation or correct incrementation.
Correct.
Now here, your int n is going to be passed by reference, not by copy. And the way you do that is just by sticking the ampersand right in front of the n, right? Put the ampersand in front of the n.
Do we also need to do?
No. In the function,
This?
It's only the function. The function.
But
on
do we
line
need to do
27.
this at the beginning
Yes,
to
we have
tell
to
the
do that too.
compiler? Okay, so I
Yes,
did that, and
yes.
then what did you say?
You need an ampersand before the n.
A what?
Ampersand is a shift 7. Shift 7.
Where? What line?
Right before the n. Int n. Just before the n, you put an ampersand. Not there. Yeah.
Here.
Shift 7.
Percent. Shift
Yeah.
7. Okay. Oh, and
Okay.
not percent. Okay.
Yeah. Now put a comment above the function, right? On hit enter on line 26. Now put a comment saying the ampersand before the n means that
How do
the
you-
actual
the
n is
n
passed and not a
percent?
copy of it. The ampersand,
Like-
yeah,
like
the
that?
and, yeah,
Mhm.
the ampersand in front of the n. The ampersand in front of the n. Don't say ampersand. Yeah, the ampersand, the and in front of the n, in front of the n, means that this function gets the actual value, the actual n itself, not a copy of it.
So a copy,
Itself.
by copy you mean a pointer?
No, a copy means another integer variable.
Oh, so you create another integer variable that's equal
Yeah,
to-
it is if you pass by copy, the compiler will create another copy of the parameter.
Mhm.
Actual
Gets the
value.
actual value. Mhm.
And not a copy. Yeah, and not a copy. Right now in here, you can say you just say n plus plus again.
Mhm.
Okay, now go to your main and copy that whole chunk that you have. Not the declaration, just line 15 to. Yeah. Now paste the blank line and then paste the whole thing. Blank line and then
Blank
paste.
line where? in the main?
Enter, hit enter, paste it again. All right, so now what you want to do is pass on line 23, to yeah, change the this will not work to this will work. Okay, change this will work.
Person.
No, just change the remove the word not. Remove the word not.
Right.
Okay, passing a value to an increment function. This will work. Okay, n equals.
Mhm.
Yeah. Okay. And you have two blank lines. That's fine. Okay. Right.
On
Yeah,
26,
sorry.
we should put correct incrementation as well, so it doesn't.
Right.
Oh
get
yeah.
confusing.
Thank you. Right. So this time, if you run it, you'll see that it actually does work because the n. Oh, gee. Hold on.
Undefined reference.
What does it say?
Correct.
Oh,
it says undefined
yeah,
reference.
Yes. Do you know why? Because
Is
we told
that-
the compiler.
Oh, wait, I think maybe I forgot the end here.
Yeah.
Maybe it's
Yes.
that.
Because the compiler says, well, you know what, you got a function, but this function is not that, so it doesn't know.
Right.
It takes this one takes by parameter a copy. Now it'll run.
Mm-hmm.
Does that make sense? Okay, it's a very simple experiment that shows you the power of passing by copy and passing by reference. It just does this automatically. It takes a copy and passes it, changes to it, won't be reflected. But if you pass with the ampersand, you change to it, will be reflected. Now, let's assume that we want to create another function which will return two values. Okay, and so say you can say int function is create a function int return two values, right? A function.
Okay.
Return two values. Return _ two values.
That's the naming convention for functions, right?
Now you can use another naming function. We're just doing this because we're in a hurry towards the end of
Okay,
class.
yeah. It's a return to value. Mhm.
So the first parameter is just going to be int n. The first parameter is going to be int n, comma, and the second parameter is going to be is odd. And it's going to be boolean.
Oh, okay.
Bool, and then by is _ odd is a variable. It's a boolean variable. You're going to pass by a reference. Okay, put an ampersand in front of it.
Underscore odd.
And then put an ampersand in front of it. Okay. Now the comment on top of this function is going to be on top of this function. This function will return true if n is if n is greater than 10, right? It will return true if n is greater than 10, and will set the value is odd to true if the number is odd. Okay, so there's two things it has to find out about the number, whether it's greater than 10 and whether it's odd, right? So it has to return two things. Yes, but it only returns one thing. So how would you return the second thing? You take the second thing passed in by a reference and put the result in that. So, the caller has both values. One of them is gotten back through the reference parameter, and the other one was an actual return. Okay, so inside of the function, all you're going to do is say, right. So bool. Actually, you don't need bool. You just say is odd equals. All you're going to do is n% double equals 1. n%2.
Oh, oops. %2.
No, not ampersand.
He means like n modulo 2.
Oh yeah,
okay.
n modulo 2. Right? N modulo 2 double equals 1. Okay, and you can put the whole thing within parentheses so that
Wait, you can
know
do
that
a
it's-
chain like this, like a chain instruction.
I'll show you.
where
I'll show you.
First, okay.
Yeah. Put a 1
Equals
there.
what?
Close the parentheses. Put 1. I'll answer your question. Right. Close and put that in parentheses so that expression starting at n%2. Right. Yeah. Put the whole thing in parentheses. So that is an expression. That will be evaluated. Right. And that expression evaluates to either true or false, depending on whether the equals, because it's just an expression, isn't it? It's a Boolean expression.
Right. So do we have to make the parentheses, or does it automatically first go to the
No, you don't
double
need the
equal and
parentheses.
then to the equal?
You don't
Okay.
need parentheses. Yeah, we just put it there so that it's cleaner because we already have an equal sign and it's harder for programmers to read. Yeah,
Is that already right? Redundant.
parentheses are optional, not redundant. Optional.
Okay. All right.
That's kind of a neat way to define whether it's true or false, though. That's cool.
Yeah, it's very
Like
common,
it-
very common. You'll find it
Yeah.
in lots of code. All right. Now you want to return if it's now you say return.
Mhm.
And what is it supposed to return? If it's greater than 10. So you can just say return within parentheses again, you can say within parentheses and greater than 10.
Turn and
Yeah, you don't
Wait.
need parentheses here because you don't.
wait, but didn't we say it returns an int though? Shouldn't that be bool? Because it returns a statement whether. n is greater than
Oh,
10.
yeah. No, it returns true. It'll return true.
Right, but I'm saying we need to change it to bool, right?
Oh,
'Cause it
yes,
was
yes.
int
Thank
return.
you.
Okay.
Thank you. Yes. And you need a semicolon after the n greater than 10.
Oh, right.
Again, that is also another Boolean expression and just evaluates and returns a value right there. Right now, you can go to your main function. Now you can go to your main, and then you can say int I don't know, m equals what did we call our function? I don't know what we call our function. The one that we just wrote. What do we call our function? The one we just wrote.
Return.
Yeah,
to
copy
value.
that. Yeah. Copy that and put it, paste it there. And then let's say the first parameter is going to be 20. First parameter is 20. And then the second parameter, we need a Boolean variable that is going to be filled in, right? So we're going to say ret val, right? Return value, ret underscore val or et underscore val. And we need to declare ret val so that we get passed in. So on the previous line, you're going to say bool space ret val, bool
Alright,
space
bool.
semicolon. No, you don't need to, because that will get filled in by the function. Yeah, you just say semicolon right there.
Oh wait, so you
Now
don't
you
have
can
to
do a
define
CL.
a value for bool? Well, you don't have to define a value if you're declaring a variable. You don't have to define a value for it, right?
You don't. It's optional. Yeah, you don't always have to do that.
Are there any that you do have to?
Yeah, it says many times when you declare a variable and then you're going to start using the variable and have to assign it a value. Some people will say, initial n equals and then do that. You can combine the two.
I'm asking if there's a variable that you have to declare a value if you're defining it.
I'm not sure I understand. Are you asking, is there a variable that you need?
Yeah, that you have to
Right.
do that, otherwise it not work, or like have to do.
No,
like
I'm
equals
saying
to
that's optional.
something.
You don't have to do that.
Okay,
you don't have
for
to do
every variable, right? For every data
Yeah,
type.
it's
any
the
variable.
same for integers, booleans, and whatnot. Is you can declare them and then set them to be things later on, which is nice.
Okay.
Yeah, you were missing a semicolon, I think.
Oh yeah. So I'm way too used to Python.
Yeah. So on the next line after 28, you need a semicolon on 28 also. Right? You can do a CO saying the function returned m and
Function returned
left shift
and
m. You need a space after returned. M.
Right. Oh, m,
M.
right.
M, and then more quote space, and ret val equals, space equals, and then ret val, and NL after that. Now, when we run this, you'll see that it'll print 0 and 1 for ret val, not true or false. That's because in C and C++, Booleans don't really exist. Booleans are basically just 0 and 1. What's going on here?
Forgot to declare that.
Oh, I see. Okay, yeah. Place it on top again. Now, so here's a very important observation here. So you see what Mark is doing? He's putting all the function declarations at the top. Now, what happens if you have 100, 500 functions in your file, right? And you have to put 500 declaration lines on top. At that time, you'll say, well, all these declaration lines are cluttering up my program. I'm going to take all the declarations and put them in a separate file. Then you'll create a separate file called a header file that ends in a .h, and you'll put all the declarations in that file. And then you say #include my declarations.h. Does that make sense?
So it will automatically read that file. You don't need to write any loop for iterating line by line. It will do it automatically.
It'll automatically include that file. And that's exactly what's happening with IOStream. Someone asked a question about IOStream. IOStream has so many functions and objects in it with declarations. It'll be a pain if you include all of that in your file and then start your main program. So they've put it all in a file and just say include this file and it'll already be there.
So you will do like hash include and then like whatever your
My
file
functions
name
.h,
is?
my functions.h. Yeah, my functions.h
Right.
or something like that.
Yeah, right. And then you will
Yeah.
close it and that'll be it, right? Okay.
That's it. Yeah.
Mhm.
Right. So now go to your main again and let's make sure it's correct. Yeah. Now if you run it now, it'll say 1 or 0. For root value will be 0 or 1. Okay. If you run it now, it'll say 0 or 1.
Mhm.
What is it? Yeah,
It
0.
says
Right.
equals
That's
0.
because it's an even number.
Mhm.
Now if you pass 21 instead of 20, the red value will be 1. Yeah, because 1 is true and 0 is false. But technically in C and C++, 0 is false. Anything non-zero is true, right? Even 1, 2, 10, 15, any number that is not 0 is treated as true, right? However, in C++, we should use true and false, Boolean variables, not bank on that like in C. In C, we used to bank on 0 and 1, but it's less readable code in C++. So we just typically say
Can
true
you
and
do
false.
that? Can you do this?
You can do that, but it's not
Okay.
recommended. Yeah,
Right.
Not recommended.
Quick question. When you're defining a function, like in Python, you can make it so there's like a inherent value to something, like you could be using like int n equals like 20. So if you weren't to define like a value for it when you call it, it'll be 20. But if you call something else and you as your like thing, it'll switch to that value. Can we do that or no?
Are you talking about a default value for a variable? If you
Yeah,
don't put
exactly. Yeah.
Yeah. All right. So this is very interesting and important question, right? C++, we actually discovered that in a previous lecture, right? C++ does not put default values in your variables. Yeah. Other languages do, but C++ says programmers know what they're doing, because my programmers who use my language, they're all geniuses, right? They know what's going on at the electron level. So C++ won't do anything for you that you don't ask, which means that you need to know every single bit, which gives you a great deal of power, right? People look at it and say, well, yeah, I got to do everything in C++ as a pain, right, to use. But the people who know how to do it say, I get to do everything in C++. That's so cool, right? So it's just which way you look at it. Right? So that's all, right? We did passing by copy, experiment more. This is not sufficient. You got to experiment more with passing by copy and reference to find out what you can pass by copy and how you can get things back. Do a lot of experimentation, discuss in the forums. I can have another class, even over a weekend is fine before the midterm. If you want another class on just parameter passing, I'm happy to do that. Walter won't be there because he's only scheduled to attend these lectures. He's welcome to be there, but he doesn't have to be there. But anytime you want, yeah.
So is this not legal? What I did, because that's how you define default variables in Python, at least. So you cannot do that in C++. Like if you don't pass
you can do that. You can not in the definition part. You can do that in the declaration part. In the declaration part, you can assign default values to variables. However, there's a clear distinction here. Note that you are the one who's putting the default value. The computer is not putting it. Right? You can't say, give me a Boolean and automatically comes to the value, right? No, you're putting the value in there. You're saying, all right, I'm going to use a Boolean.
But you can't have a default value. I'm saying default value that for the function. So if the user doesn't put anything, it automatically fills in.
You can, just like you did, right? Except that this won't be here. It won't be here. It'll be in the declaration, in the header file, right? The declaration you have up there.
Oh,
that's where
you mean like here. You mean like
that's
here?
where you put the default. Yeah.
Okay, I see.
And you don't put it in the definition, right? You shouldn't put it in the definition. You only put it in the declaration. But these are, not really conceptual. These are things that we have to remember, unfortunately, right? So these are things that, oh yeah, default value needs to go there and not here. There's no basis for it. It's just a decision, arbitrary decision, really. But it works. It works, and we just stick with it because it's not a significant thing. It's not going to make or break your day. So we just live with it. Does that make sense? I think we covered everything except static variables. Static variables, well, okay. I decided that we'll talk about static variables later on when we're talking about classes, because classes can have static members. Very similar to class, static variables and classes in functions. We'll do that. That's all. What time is it now? Wow. Hey, Adam, I thought you had another class. Oh, Nemo's gone. Right. Some of you have a class and they've gone. Nemo's gone,
My
right?
my
Adam and
in-person
Nemo.
class is on Tuesdays. Is only on Tuesdays.
Oh,
I
is
don't
it?
have it on Thursdays. Yeah.
Oh, cool.
So I get to
Well,
stay here.
thank you
and
all so much
get
for
to the
sticking
training.
around, humoring me until, even past the class and time and all. Thank you all so much for sticking around. And we covered all of the essential material. If any of this material, not just what we did today, any of the material from day one until now, including data representation, anything is unclear and you want an extra class, and a full extra class, 2 hours, any number of extra classes before the midterm, all you need to do is just ask and I'll just be there, right? I'll set up a class at a time when most of you can make it. I'll do it. It doesn't take me any effort, right? I'm just sitting here, I'm just talking what I know already, right? And we're having fun. We're having fun. We talked about some cool jokes and all, right? So we can do that again. I can do that, all day, really. I don't care. So feel free to ask for more classes. And same thing, even when you're doing 2B and 2C, right? Walter knows, even after Walter completed 2C and exams, we still worked on some fun projects together, right? Splay trees and all, you and Riley and I. So we did a lot of cool stuff. I'm happy to do this, right? This is stuff that I find fun. So even if I'm doing something else that's fun, I'll say, oh, well, okay, I'll take a break and do this and come back. It's like that for me. So I don't care. So it'll be good for me too, and entertaining. So thank you all so much. Okay. So and a happy midway point to the course, because next week onwards we'll start looking at objects and classes. Exciting stuff, really exciting stuff. Okay, now totally set you up for 2C, 2B and 2C if once you get past those things. And yeah, and although you can just pass 2A by acing quest number 6, which is just superficial knowledge of objects, I would say don't stop there. Go all the way to the end and do 2B also. You will have a great
Professor,
experience.
what do I do if this line gets overboard? Should I just use a new print? Should I just print until here? Can you see the share screen?
Yeah, I can.
So
I see,
this
it's
line
beyond
is
the 80 columns.
overboard. Right.
Yeah.
So do I just do a new print? Do I print that and then do a new
here's
print
the better
without
way to do
end
that.
line?
You could remove the semicolon and then bring it down to the next line with you. So like you could just hit enter on the other side of the left shift or before it still works.
You mean like here?
As long as that's fine.
But
yeah. So but okay, all right. So put a quote. All right. So what you want to do, Mark? Put a quote after function. Put a quote after before this will not work, right? Put a quote, double quote after there.
So quote.
Right? Space and then a quote. Space and then a quote. Right. Now
then...
next line after that. Next line. No, just next line.
Oh, I don't need to close it. Okay.
Enter. Hit enter. Enter. Hit enter. Right now, put a quote there. Double quote there. Just double quote. No, one double quote, and then indent that whole line in to the 2 double quotes lined up, the previous line and this line. Okay. Strangely enough, okay, this is something you won't find this in any textbook. It's actually part of the C++ standard, and nobody actually reads the standard. Everybody programs C++. Very few people go and read the standard. I didn't read the standard, but I discovered that strings, naked strings like this, these are called literal strings. If you just have 2 string literals next to each other, they automatically get concatenated in C++. Okay, that's a feature in the standard that very few people know. Now, if you run it, it'll actually work. Oh, you need a space before. Yeah, that's fine. If you run it, it'll work. It'll work, right? Because the 2 strings just get concatenated next to each other. Yeah, did it work?
Right. 1 second. Yeah, I did.
And you can also do what Adam or someone suggested. You can also left shift. You can put a left shift operator on line 21. On line 21, before the double quote, you can put a left shift operator there too. Not there, on the next line. On line 21. Right before the first one. Yeah, put a left shift there. That'll also work.
Oh, okay.
But if you don't have that, the strings get concatenated and then set.
Okay.
All right.
How should I call this file?
You can say, class experiments dot. I don't know. You guys come up with a good name, right? Class experiments, parameter passing or something like that.
I think maybe passing through parameter copy versus reference. Passing parameters.
Yeah, or
copy
the
versus reference.
params.c++ even. Params.c++.
Oh, do I have to sign in order to save it? Oh,
I
Um,
think you can just hit download, yeah.
Yeah.
okay.
You
And
can
then
also get a
post it on
share
Reddit.
link, by the way. If you click the orange button will give you a share link.
Yeah, I think this is better actually.
Yeah.
Okay.
I found out that, when you share a link like that, the code will stick around for 1 year. After 1 year, they basically delete the code. Yeah, it's okay. But in Reddit, it's always there. But it doesn't matter really, because who's going to look at this code after a year? All good now? Everybody okay?
Yep.
All right. So did you guys have a good class? I mean, was it useful and interesting? Yeah.
Yep.
Thank you. All right. So I will look forward to seeing you all on Tuesday, because your midterm is on Thursday. Okay. So, and I'll wish you good luck for your midterm on Tuesday. All right. Enjoy the weekend and happy coding.
Thank you. Bye.
Thank you.
Bye.